Welcome back. This is an Aleks teaching video on predicting whether simple electrochemical reactions happen. I love this question. I think it's hard, but I like it a lot. I think it teaches you very well. So if you pay kind of close attention, you're asked to see whether a chemical reaction will happen or not. And at first you'll read this and scratch your head and go, well, how in the world do I know if it happens or not happens? Okay, there's a piece of information you don't know yet that's in your book that I'll point to you to in just a minute. But let's first of all see if we understand what we're being asked. The first one is a strip of solid iron metal. So I'm just going to write it out, iron. So it's solid iron metal. So I'll put solid. Is put into a beaker of so much molar nickel chloride solution. Okay, so let's ignore the molarity for a minute and just say that there's some nickel chloride in it. So I have nickel 2 chloride. Now this is aqueous. And so what's going to happen? Well, what could possibly happen? You've got something by itself. You've got one metal by itself and a metal, a salt here, a metal and a non-metal acting as a salt. Well, this is a single displacement reaction. If you remember, this comes in and kicks out the nickel, and then you'll end up with nickel by itself, solid nickel, plus iron chloride. So iron 2 chloride. All right, so that's all you can have. Right? What's the second reaction? Second reaction is you put nickel, okay, which is solid, into a beaker of FeSO4 solution, aqueous. So what could possibly happen? The nickel is going to come in and kick out the iron, so you're going to end up with iron metal, and then nickel 2 sulfate. Okay. Well, these are backwards of each other. Here's iron kicking out nickel, and here's nickel kicking out iron. It's not going to happen both ways. What you're going to see is that some girls will leave their boyfriend for certain boys, but won't leave their boyfriend for just any boy. Okay? So there is a ranking of metals that you're going to see. It's in your book called Activity Series. In your book, it's on page 143. And anything high on the list can reduce anything lower on the list. Okay? So remember, a reducing agent is something that can give away electrons easier. So the higher it is on the list, the more likely it is to give away electrons and make whatever it's reducing more negative. Okay? We're going to see that that iron is 2 higher than nickel. Iron is 2 higher than nickel. So that means iron can reduce nickel. So let's find out what these oxidation numbers should be. Okay, here's iron. It's by itself at 0. Here's nickel. It's by itself at 0. Here's nickel with chlorine. Chlorine is in group 7. It's -1. There's 2 of these, so it's -2. That has to be +2. Here's group 7. There's 2 of them. It's -2, so this has to be +2. So what's going on? Iron is being oxidized, and nickel is going from 2 to 1. Nickel is being reduced. Nickel is reduced. Okay? What's happening here? I've got nickel by itself, that's 0. I have iron by itself, that's 0. Sulfate's -2. That means that has to be positive 2. Sulfate's negative 2. That has to be positive 2. Nickel is going from 0 to 2. Nickel is being oxidized. Iron is going from 2 to 0. So in this case, iron is reduced. Okay, so nickel is being reduced by iron. Iron is being reduced by nickel. Okay, now just because I write it down doesn't mean it happens. So in reality, only the things higher on the activity list can reduce something lower. And iron is higher on the activity series than nickel. That means iron can reduce, okay? In reality, iron reduces nickel. Okay? Nickel does not reduce iron. Okay? So this one cannot happen. It can't happen. Just because I write it down doesn't mean it. So if I do put a strip of solid nickel metal into a beaker with iron sulfate in it, nothing would happen at all. It would just sit there. Nothing, no reaction. But if I were to put a strip of iron metal in a beaker with nickel chloride, what would happen is the nickel would start forming a metal, and the iron would start being eaten away. The iron would eat away, and the metal would the nickel would come out of solution and plate the iron. I would have nickel plated iron. Okay, so that means one of these can happen. This can happen. This can't happen. You would not know this from just your smarts. You have to look it up on the activity series. Whatever's higher on the series can reduce whatever's lower on the list. Okay, so that means I need to do just the top one. And what's it going to look like? I'm going to simply write this down. I'm going to say Fe solid plus, let's see what they're asking for. Write the chemical equation for it. Be sure your chemical equation is balanced and has physical state symbols. I'm not sure. I can write it two different ways. You can check to see which one is right. I have a guess which is right, but I'm not sure. Okay. I have iron first, so let's write the iron first on this side. I just don't want you to get it wrong and have the right answer and still get it wrong. So iron, nickel. This is aqueous plus nickel solid. My thinking is if this doesn't work, then you need to just show the metals. Okay, because the non-metals are simply going to be, these chlorides are just going to be spectator ions on both sides. So if this is Cl2, this is going to be positive 2. And if this is Cl2, this is positive 2. So you could write Fe plus Ni2 plus aqueous yields iron 2 plus that's aqueous plus nickel solid. Okay, and then just leave this one alone. So this is yes and this is no. Okay, these are both right. You're saying the same thing. I just don't know which one Alex would use since it's a computer program, but you can check it out.